In this video, we're going over the memorization approach of dungeon games. So previously in the recursive approach, we have gotten our TLE error. Now we're going to optimize it using our memorization approach. So let's go over the thought process. So in the recursive approach, the solution is not efficient enough due to overlapping recursive calls. Now we can avoid overlapping recursive calls using memorization. Now, what do we need to cache? In each of the recursive call, we are trying to find the minimum health, min health, at the current cell RC. This means we can cache RC with min health. Now let's go over the pseudocode. So we're going to create a 2D matrix, Memo to cache previously calculated results. So the rows represent R, the columns represent C, and then the values represents min health. Then we can implement the top-down memorization approach. We're still going to pass in our current row and current column, the input matrix, the number of rows, the number of columns, and also our cache. So what's the base case? If RC is equal to M and n-1 or n-1 and n, this means the knight has already saved the princess. And after the knight has saved the princess, the HP should be equal to 1. So we return 1 here. If RC is out of bound, this means it's an invalid cell. We can just return an error code, which is a max integer value, which means the knight should never step into this cell. Now, if Memo RC is not equal to 0, this means we have already calculated the results for the current cell. So we can just return Memo RC. Then we're going to recursively find the minimum health of moving rightward, which basically just increasing our column by 1 by moving rightward. And then we'll recursively find the minimum health H2 of moving downward, which basically just increasing our current row by 1. And then we'll find the health at the current cell, which basically take the minimum value of the 2 HPs and also subtract the current cell. Now, if health is less than or equal to 0, actually this should be or equal to 0. This means we currently have a valid health. We're going to put 1 at Memo RC. We want to cache it. Else we can put health at, if health is less than or equal to 0, this means it's an invalid health. Is invalid health, this means any positive integer of, or any positive health will allow the knight to stay alive at the current cell. So we want to place the lowest positive value, which is 1. So we want to put 1 at the current cell or at the current cache. Else the health is a positive value, so we can just put health at Memo RC, then we can just return Memo RC. Now let's go over the time and space complexity. For the time complexity, let's go to Mn, because there are Mn states with RC, or possible states. Our space complexity is m plus n, and also m times n. This is because of our Memo matrix. Now let's go over the code. So let's bring these two out. The current row, the number of rows, and the number of columns. We're going to create our matrix to cache previously calculated results. And then we're going to pass in our Memo. Now we go over our base case here. The first case is after we save the princess. The second case if the current cell is invalid. Also, if Memo RC is not equal to 0, we have already calculated the results for the current cell, so we just return Memo RC. We calculate the minimal HP of moving rightward and moving downward. also pass in our cache. And then we find the minimum health of staying at the current cell here. If the health is greater than 0, then it's a valid minimum health. We can just return health. If it's less than or equal to 0, we want a lowest positive value to represent the health of our knight. So we just return 1. And before we return it, we're going to cache it too. So Memoirc is equal to the health. Let me know if any questions in the comment section below.